Here we're going to be looking at question 36 of the ENGAA 2018 paper. In this question we're given the following scenario. We have a plank of mass 10 kilograms resting on two supports X and Y. On the plank, 1 metre from its centre, we have a block of mass 40 kilograms. The question asks, what is the contact force at X? So in this question we're being asked about force at X. So why don't we go ahead and label our force at X and all the other forces that we can think of on our diagram. So we have our contact force at X, we have the weight of the block, we also have the weight of the plank, and then we have another contact force at Y. The weight of the block is just going to be its mass multiplied by the acceleration due to gravity, and that'll be the same for the plank as well. If we go ahead and look at our diagram again, then we'll notice we've got a plank going across two pivot points. Now, are there any topics this makes you think of straight away? Well, you'd be right if you think moments. They're a topic which we generally have to use whenever we have forces with pivots involved. So since we want the contact force at X, and we don't need anything to do with the force at Y, how about we take moments around Y? Now, if you can't remember, the moment due to a force is equal to the force times by the distance from the point you're taking moments about. So, if we're taking moments about Y, then the distance from the force at Y to Y is just going to be 0, so it won't have any moment at all. If we go ahead and look at the other moments, then we're going to have anti-clockwise moments due to the weight of the plank and due to the weight of the block. We're then going to have a clockwise moment due to the contact force at X. So writing this mathematically, we have the distance of the force at X from Y, which is just our 4 metres, which is going to be equal to our two anti-clockwise moments, the moment due to the block, which is its weight, multiplied by the distance of the block, multiplied by its weight, plus the distance of the centre of mass of the plank, multiplied by the weight of the plank. If we then go ahead and rearrange this for X, then we get this, which we can simplify to get 1,400 divided by 4, which comes out to be just 350 newtons. This will correspond to answer F.